Hey guys, welcome to the video for literal equations. We're in Unit 1. Our essential question is, how can equivalent representations help me become an efficient and effective problem solver? So the lesson over literal equations can be a difficult one for students just because it involves a lot of variables and it's something that's kind of unfamiliar for us. But again, the goal of solving equations is always going to be the same. We're looking for that specified variable or isolating that variable. So let's go over what is a literal equation. So a literal equation is an equation made up of multiple variables. So this could mean that it's made up of 2 variables, 3 variables, however many. So it's basically more than one. So instead of just dealing with one variable and getting that one variable by itself, you're going to have a few variables and ask to isolate one of them. So again, what does it mean to solve? Well, when we solve an equation, we're trying to always get x by itself or the variable, whatever is asking for. Well, with literal equations, it's the same goal, and they're going to specify to you which one they want you to isolate. So what does it mean to solve? It means you want to isolate the specified variable. And I'll go ahead and give you some examples of literal equations. And there's some equations that you've seen before. So for example, some literal equation examples would be A equals L times W. Area equals length times width. That's the area formula for a rectangle. That is a literal equation. Or maybe V equals LWH. Volume equals length times width times height. Those are literal equations. They're made up of variables of more than one variable. It can also consist of numbers as well. All right, so now we're going to solve both equations for x, and I want you to notice kind of the similarities that you see between both problems. So we're going to go ahead and start on the left. Something that we're more familiar with is isolating a single variable. So here, in order to isolate this equation, the first thing I would do is I would subtract 3 from both sides. Anything you would do to one side, you want to do to the other side. So I have 5x equals 8 minus 3, which is 5. My next step here would be to get rid of the 5 in front of the x that's attached to it. Because they're connected by the operation of multiplication, I'm going to do the opposite and divide. 5 divided by 5 over here gives me 1, so I just have 1x. And then 5 divided by 5 is 1 here. So the solution to my equation here is x equals 1. I get a solid whole number as my solution. Let's move on to this example, okay? Now, the goal here is you're trying to solve for x, okay? You're trying to isolate the variable x. So in both cases here, in both equations, both the left one and the right one, the goal is to get x by itself. Now, you're like, okay, well, I don't really know what to do first because this has a bunch of variables next to it. Doesn't matter, right? Just because they're variables doesn't mean you treat it any different. So how would you get this x by itself? Well, let's go ahead and take a look at what our first step here was. Okay, it looks like we subtracted the 3 first because we notice that it's next to the 5x and you always want to add or subtract before you multiply and divide. So over here, my first step would be to subtract the y over. Y minus y cancels, becomes 0. And what I have left is 5x equals, now over here I have m minus y. Now remember we talked about like terms. You're only allowed to combine things if they are like terms. M and y are not like terms, so I cannot combine them. So what do? You just write them right next to each other. M minus y. There's not much you can do there, so you're just going to leave it as m minus y. Now, the next step here, again, what is the goal? I want to get x by itself. So I don't really care what's going on the right side over here. I'm trying to pay attention to this x to see what I can do to get it by itself. That 5 is attached to x by multiplication. So the only logical thing to do here would be to divide by 5 and get rid of the 5. So what I'm going to do is divide this variable by 5. So the 5s are going to cancel because it becomes 1. And all I have left on this left side is x. So what does that mean? It means I also have to divide the other side by 5. And here is what I'm going to tell you. You have 2 separate things going on this side rather than just one. You have 2 terms. So anytime you have to divide and there's more than one term, you need to divide everything by that. So I need to divide the m by 5 as well as the y by 5. So I divided on one side, I got to divide everything else on the other side by 5 as well. It's just like when we do multiplication and we have like x plus 7 equals 2, right? If I want to distribute this 3, I got to distribute it to every term. So I would distribute it to the x, to the y, and, not the y, the 7 and the 2. I would distribute it to everything. So just like with multiplication distribution, I would divide everything by 5 here. So m divided by 5. Can I simplify this? No, because I don't know what m is. So I'm going to leave it as m divided by 5 minus y divided by 5. Okay, now the goal here is to get x by itself. Did we do that? Did we isolate x? Yes. So this is actually your final answer if you cannot simplify any further. So what was the difference between the left side and the right side? Well, with the left side, obviously there's only one variable. And it's a little bit easier for us because we know how to combine numbers, we know how to combine those and simplify those down. Whereas the right side, it's a little bit different because you have a bunch of variables going on. You can't combine things as what you want, right? That m minus y at the very beginning, you can't combine that, so you just gotta write it next to each other. And then over here, when we divided by 5, we divided it by all the terms on both sides. What we did to one side, we did to the other side. But over here, there was only one term. Over here, we have two separate terms, so you want to make sure you divide by 5 to everything, and you want to do it to both of those terms as well. And the reason why we leave it like this is because we can't simplify it. We don't know what y is, so we can't divide it by 5, and we don't know what m is, so we can't divide it by 5. So it looks really weird, but you would just leave it like that because you've done what you needed to do, you simplified what you needed to simplify, and that's really it. All right, so we're going to go ahead and start. Solve the following equations for the specified variable. So it's going to give you a variable they want you to solve for. So number 1, we have 2x equals 8m for x. So they want you to solve for x this time, okay? So that means I want to isolate x. So I'm going to always highlight the variable I want to get by itself. That's what I want to get by itself. So if I'm trying to isolate x, what's the only thing holding x back? The 2 in the front. 2 is connected to x by multiplication, so I would do the opposite and divide by 2. And I would divide the other side by 2 as well. Now here we only have one term, so I only have to divide 2 once. Okay, 8m is one single term. All right, now 2 divided by 2 cancels and becomes 1, so I have 1x equals. Now over here we want to simplify. Can I do 8 divided by 2? Yeah, 8 divided by 2 is 4m. So 8m divided by 2 would give me 4m. Now, did we do what we were asked to do? Did we solve for x? Yes. So that means I'm finished. All I was asked to do was isolate x, and I did that. Now, it might look a little bit weird because there's still like variables left over, but that's okay. You did what the goal was, right? You did what you needed to do. All right, number 2. 2m plus y equals 7, and we're asked to solve for y. So I'm going to go ahead and highlight the variable that I want to isolate myself. I want that y to be by itself. Well, what's on this side of the equation that's holding my y from being by itself? Well, it looks like that 2m is what's in the way. Now 2m over here is being added to y, so they're disconnected from each other. So that means I can take the 2m and I can move it to the other side. Now I would move it to the other side by subtraction. And you're like, I'm confused. So let's give you another example. Let's pretend that m wasn't there. Let's pretend the m's not there. How would you get y by itself here? Well, you would subtract the 2 over, right? And then you get y equals 5. You get rid of that 2. You would do the same thing here. It's just that that 2 has an m attached to it. So I'm going to subtract the 2m from both sides. Okay? So 2m minus 2m goes away. And what I have left is y equals 7 minus 2m. Now these are not like terms, so I cannot combine those. So I would literally just write them next to each other. Did I isolate y and get y by itself? Yes, so I'm done. All right, moving on to number 3. A equals L times W. Now this is the formula for the area of a rectangle. Like area equals length times width. Now here we're asked to get W by itself, okay? So I'm going to highlight W because that's what I want to isolate. Now the only thing holding my W being isolated is that L in the front. Now that L is connected to W by what operation? By multiplication, right? L and W are being multiplied together. So to get rid of the L and get W by itself, I would want to do the opposite and divide by L. And I'm going to do the same exact thing to the other side and divide by L. You treat it just like you would treat a number. For example, A equals 4x, right? To get x by itself, I would divide by 4. So you can actually divide variables out too. It is allowed, I promise. Now, L divided by L over here is going to cancel, because give me 1. And I'm going to have W left over, right? Because my L's canceled. And then over here, I have A divided by L. Well, A and L are not like terms, so I cannot combine them, so I would leave them exactly the way they are. Now, this feels super unnatural because you're like, this doesn't feel This doesn't feel like it's supposed to be this way, but it is. It's going to feel weird at first. Again, literal equations is just a lesson that we struggle with. So if you are struggling a little bit with this, that is perfectly okay. It's normal. But the goal is you're going to get that variable by itself regardless at the end of the day. Now, number 4, similar to the problem, or similar to the example I gave you at the beginning, V equals LWH. And you're asked to solve for H. Now, this is the volume formula of a rectangular prism. You're asked to find the volume of a rectangular prism. You do the length times the width times the height. Now, the goal here is you want to get H by itself. It wants you to isolate for the variable H, okay? Now, what's holding H back from being isolated? Well, right now it's being multiplied by L and W. It's being multiplied by L and W. I want to get H by itself. So to get rid of the L and the W in front of it, I have to do the opposite operation. And the opposite operation here would be to divide. Because L and W are being multiplied, I have to do the opposite and divide L, W out. Okay? Anything I do to one side, I have to do to the other side. Divide by L, W. Now, the L's are going to cancel. L divided by L gives me 1. They cancel. And W divided by W also cancels. All right? So then all I have left is the H on this right side. So I've isolated the H. And then over here when I look, V divided by LW. Well, there's not really much I can do there, right? Because they're not like terms. So I would leave it as exactly is. Or as exactly as it is exactly. I wouldn't mess with it. I'm not going to do anything extra funky to it. It is what it is. Not much else I can do. All right. Moving on to number 5. Now this is the first tricky one that we see. G equals 2 divided by H, and we want to solve for H. Oops. Now this one is tricky because what we want to solve for, we actually have to move around a little bit. So first of all, we hate fractions. We always hate fractions in math. So how do we get rid of fractions? Well, like I taught you the other day, when you want to get rid of fractions, you want to multiply by the least common multiple. So you always look at the denominator to see what you need to multiply by. So for example, we had that one problem that looked like this, right? And you were asked to look for the denominators and then you compare the least common multiple. Well, here's the problem. There's only one denominator here and the denominator is H. So to get rid of that H in the bottom, right, I'm going to multiply by H. So it's being divided by H, so I'm going to multiply it. And the reason why I'm doing this is I'm trying to get rid of the fraction, okay? I'm trying to get rid of that fraction here. So I'm going to multiply this by H. Because the 2 is being divided by H, I can undo this fraction by multiplying it by H. But if I'm going to multiply by H on one side, I have to multiply by H on the other side. Okay? Now H divided by H on this side will cancel because you're dividing it. It was being divided, now you're multiplying it, so you're doing the opposite, and so you're canceling out what's happening on that right side. You're canceling all of this over here. So all you have left on the right side is 2. Okay, you have 2 left over. So what do you have left on this side? Well, you have H times G. HG. Now again, you can write the multiplication sign if you want to, but typically we don't. Typically when letters are right next to each other or a number and a letter are right next to each other, you know they're being multiplied. So again, let's go back to this. Why did we multiply by H? We wanted to get rid of the fraction, and we saw that it was being divided by H, right? So we did the opposite and we multiplied by H to get rid of it. You will have a homework problem in a couple of maybe quiz or test problems that are similar to this, so it is important that you look at all those tricks and see all the things that you can do. This is not easy for everybody, so if you find this difficult, again, it is okay. All right, so now what do I do? Well, my next step here would be I gotta solve for H. Right, now my fractions are all gone now, but I gotta still isolate and get H by itself, and I haven't done that yet. So how do I get H by itself? Well, the thing that's holding my H back from being by itself is the G that's attached to it. Well, how is the G attached to it? The G is attached to the H by multiplication. So you're going to do the opposite and divide by G because it's being multiplied. And you do the exact same thing on the other side of your equation sign. So G divided by G will cancel. It cancels out and it goes away. So all I have left is H on the left side, and then 2 divided by G. I can't simplify that. I don't know what G is, so I'm going to leave it as 2 divided by G. And that is it on that side. I'm going to go ahead and make this a little bit smaller. Okay, so is H by itself? Yes, I got H by itself exactly as it asked me to do. So again, your goal is just to do whatever it asks for you to do. So if it's asking you to simplify for h, solve for h, then you're going to solve for h. This one was a little bit weird because we actually had to move the h around before we could even get it by itself. All right, number 6. And I'm just making sure we have just 2 pages left. So we're actually doing pretty good. And we're almost done with the second page here. So number 6, we have 1/3 times xyz equals 5, and we want to solve for x. Okay, now typically, we see parentheses, we want to get rid of them. However, we're trying to solve for x, and the only way to do that efficiently is I want to get rid of that fraction first. Again, we hate fractions, so let's try to get rid of it. How do we get rid of fractions? Remember, you look at that denominator. You want to look and find the least common multiple of your denominators. You only have one denominator here, okay? So just like the other day, you had 1/2 plus 1/3, x equals 6. You looked at your denominators and you compared them. So you're like, okay, multiples of 2, and then multiples of 3, right? We had all these multiples. I'm going to find the least common multiple between those two denominators. Well, in this problem, in number 6, there's only one denominator here. So I really don't have to work very hard. I know that I have to multiply this by 3. And the reason why I have to multiply this by 3 is because it's the only denominator. So I'm going to multiply this whole thing by 3. Okay? Now, I want to point you out to something. This right here is one term. Remember what a term is, right? A term is separated by plus and minus signs. So for example, x plus 2 here. When I multiply by 3 here, I have to multiply by 2 separate things because there's 2 terms here. But if I have to multiply for x, y, z, I only have to multiply this once because this is one term. It's a big term. It's a huge term. There's a lot of variables, but it's one term. There's no plus or minus signs separating things, so you do not have to distribute more than one time. So again, notice this is one entire term. So when I distribute this 3 in, when I distribute this 3 in, I'm only going to multiply it once. So 3 times 1/3. 3 times 1/3. Well, if I do that in Desmos, and this one is one of the trickier ones on this assignment. So 3 times, and let me go put on projector mode so you can see, 3 times 1/3 is 1. So I do 3 times 1/3, I get 1, and then x, y, z. Okay? Now you can keep the parentheses there if you want, if that makes you feel a little bit better. Now again, that's still one term. Now they could have written this a different way, right? They could have just written 1/3 x, y, z. They didn't need those parentheses there, really. But they did that to make it a little bit more confusing for you. So if you want to leave the parentheses there, you may do so. Oops. And actually, I need to change this to a different color because orange is my highlighting color. So I'm going to change this to purple. Actually, that's hard to see. Oops. Come on. Pink. There we go. All right. So I have 3 times 1/3 gives me 1. So that's why there's this 1 here. Now, do I have to write that 1 in the front? No. And then you also want to make sure you multiply it to the 5 because 5 is its own separate term. So equals 15. 3 times 5 is 15. All right, this one's a little bit confusing. Just letting you know. It is a little bit confusing, I understand. All right, now, again, you don't have to write that 1 in the front, so you really can just get rid of it and get rid of those parentheses as well. Okay? Now, here, goal is to get rid of the x. And actually, I'll write the 1 here, and then I'll rewrite the steps so that you could know that you can just drop it. So x, y, z equals 15. There you go. All right, now we want to get x by itself. Well, what's holding x from being by itself? Okay, well, x can't be by itself because y and z are attached to it. Well, y and z are attached to it by multiplication. So I'd want to do the opposite, and I would want to divide y and z out. So remember, when you're trying to get rid of stuff, you always do the opposite. So because they're being multiplied, you're going to do the opposite and divide. So y divided by y is going to cancel. Z divided by z is going to cancel. And all I'm going to have left is this x equals 15 divided by yz. I can't simplify that because, well, I don't know what y and z are. So I would just have to leave it as 15 divided by yz. And x is by itself because it wanted me to solve for x. All right, number 7. Now, this one is going to be one that tricks us sometimes, and it is because there's going to be some simplifying involved. I don't really remember why I have the star there, but maybe I will remember in a second. So, all right, we have 3x minus 2y equals 6. We want to solve for y. Okay, now when we're solving for y, we want to get y by itself. So let's look at what we have here. Well, in order to get y by itself, I need to get rid of the 3x, and I need to get rid of the negative 2. Well, let's say, example, I didn't have the x there. Let's say I had this. Now, this is just an example. Oops. So this is the exact same thing as I have above, except I don't have the x there. So in this case, if I wanted to get y by itself, what would I do? Well, I'd want to get rid of the 3 first. And I would get rid of it by subtracting it from both sides. So I would do the same thing here. I would want to subtract the 3x from both sides. 3x minus 3x goes away. All right? So then I have negative 2y equals 6 minus 3x. Now, why can I not combine those? Well, 6 and negative 3x are not like terms, so you cannot combine them, so you don't want to force them to be combined, okay? All right, now, what's the goal again? Okay, yeah, we need to get y by itself. So again, we're highlighting y, but that's the variable that we want to get by itself. Well, what would I do next? Well, again, we want y by itself. What's holding y from being held back by itself? That negative 2 in the front. How are negative 2 and y connected to each other? They're connected by multiplication. So I would do the opposite and I would divide. Now I'll divide this by negative 2, all right? So I would get rid of that and it would cancel. And I have to divide by negative 2 on the other side also. How many terms do we have on this side? We have 2 terms. So I'm going to divide them both by negative 2. Remember, however many terms you have is how many terms you're going to have to divide it by. You want to make sure you divide it by everything. This is super important. We're going to use problems like this problem number 7 is going to be so important in Unit 3. You're going to do it literally almost every day in Unit 3. So it's super important. So over here on the left, we just have y by itself because negative 2 divided by negative 2 is 1 and it canceled. And then here we want to simplify. So I think the star over here says simplify if possible. And I think I want to put always simplify if possible because you always want to make sure you can simplify. Always simplify. Always simplify if possible. Now, this one is a little bit tricky, right? Because we want to be super, super careful. And there's a couple mistakes that we can make here, so we want to be really careful about that. Now, 6 divided by negative 2. I want to see if I can simplify that, and I can. 6 divided by negative 2 gives me negative 3. Okay? And then I have negative 3 divided by negative 2. Well, you can put negative 3x divided by negative 2, but you can actually simplify that. I want to point something out to you. A negative divided by a negative is a what? A positive. A negative divided by a negative is a positive. So you want to be super, super, super careful about that. Now, I remember why I put the star over here. Okay, and I'm actually going to make a second star. And I'm going to show you something. 3x divided by 2. Actually, I'll use a different number. I'll use 4x divided by 5. Okay? There's another way you can write this, and this is the way I prefer you to write it. So you can actually write it as 4/5 and then a big X next to it. The X is not in the top. It's not in the bottom. It is attached to the 4/5. Okay? So just same thing here. If I have 2x over 7, that is the same thing as 2/7 x. They're the exact same thing. Just like saying if I have half of x, so I take x and I divide it by 2, that's the same thing as doing a half times x. It's the same exact thing. You're like, where'd that 1 come from? Well, really, remember, there's a 1 there. We just don't write it. So again, you can actually write out the fraction to the side and write the x attached to it, which is exactly what I'm going to do here. So negative 3 divided by negative 2 is positive, is positive 3 over 2. Remember, negative divided by negative is a positive. That's why there's a positive sign here. And then I'm going to write 3 over 2 and then an x attached to it. Now, how do I know I'm finished? Well, I've simplified if I can, right? It's always simplify if possible, so we simplified that. And we want to make sure that y was by itself, which it is. All right, moving on to the last page. Number 8, ax plus by equals c. Solve for x. Well, I want to get x by itself, so what would I do here? Well, hopefully you see that you need to subtract by. Okay? The most common mistake here is that people say, oh, I need to get x by itself, and then they divide by a. They divide everything by a. And I'm like, okay, why are you dividing by a? And they're like, well, I need to get x by itself, and x has an a attached to it by multiplication, so I do the opposite and divide. That's correct. However, you always add or subtract before you multiply and divide. The backwards of PEMDAS, right? You always add and subtract first. Because I can subtract a by, I have to do that first. If you divide by a at the very beginning, it is going to be confusing. You'll probably make a mistake, and it probably won't be correct. So, my advice to you is to add and subtract before you multiply and divide, and that is why we're subtracting by first. So positive by minus by cancels and becomes 0. So what I have left is ax equals c minus by. Now c and by are not like terms, so that's why I can't combine them. Now again, what's the goal here? We're trying to get x by itself, right? So x is still not by itself. There's an a attached to it. A is attached to it by multiplication. So I'm going to do the opposite of multiplying by a and divide by a. Okay? And you have to divide by a by every term that you see. So c is its own term, so I'm going to divide by a there. And by is its own term, so I'm going to divide by a here. Okay? So a divided by a on the left cancels and becomes 1. So I have x equals c divided by a. I cannot simplify that. They're not like terms. And then minus by divided by a. That's all I did. That's all I have to do. I got x by itself. I accomplished the goal that they wanted me to accomplish. So we're finished. We solved for x. Again, it looks super weird because there's so many variables there. So that's why it can be a little confusing. All right. Number 9, 5w minus 8 minus 3w equals 6z. And we're asked to solve for w. So the first thing I notice here is I actually have two w's. And what else? They're on the same side. So what can I do? I can combine them. 5w and negative 3w are like terms. So 5w minus 3w gives me 2w. And then I have minus 8 equals 6z. All right, again, what's the goal here? I'm asked to solve for w. I have to get w by itself. Well, the first thing I'm going to do is I'm going to add 8 first. So I'm going to add 8 to the other side as well, because anything you do to one side, you have to do to the other. And you have 2w equals 6z plus 8. Are we finished? No. W is still not by itself. So how do I get that w to be by itself? Well, I need to get rid of the 2. The 2 is attached to the w by multiplication. So I would do the opposite and divide by 2. And when I divide by 2, I need to divide every term by 2. So 6z gets divided by 2 and 8 gets divided by 2. All right. I probably need to start writing smaller so I can fit all of this stuff in here. All right. Now z divided by z is going to cancel. Oops, that's a little too large. Z divided by z cancels, right? Not z, sorry, 2. 2's and z's look very similar to me, so that's why with my z's I have a line in them, and 2's I do not. 2 divided by 2 cancels, becomes 1. So I have w left over. And then 6z divided by 2. Well, 6 divided by 2 is 3. So it's going to be 3z. Okay, 6z divided by 2 is 3z. And then I have 8 divided by 2, which is positive 4. Is w by itself? Yes. So we are done with this one. Go ahead and shrink that as well. Okay. Moving on to number 10. 1/4 parentheses 8h minus 12g equals k. Now, just like the last problem, or just like that other parentheses problem, there's a couple ways you can do this. Now, sometimes you can distribute and sometimes you can't. And here's where you can't distribute. Earlier I said, hey, that 1/3, we got to get rid of it. We got to get rid of it by multiplying by 3. Why did I do it by that? Why didn't I distribute instead? Well, here's the problem. There's nothing to distribute it to because it's only one term. right? The stuff in the parentheses is only one term, so it wouldn't have made a difference really. And here's why I'll show you. 1/3 xyz. I can distribute this, but then I just get 1/3 xyz. That's all I would get. That's the only thing I would get if I distributed this. So that's why I didn't do it, because again, there was no point for me to do it. So that's why, oops, give me 1 second. Okay, that's why I did not do that. And if I were to do that, it wouldn't have made a difference. It would have just been a waste of time, and I would have ended up pretty much back where I started. So that's why I didn't distribute. Now notice on number 10, how many terms do we have in that parentheses? We have 2 terms. Again, in the last problem with the parentheses, there was only 1 term inside the parentheses. Here we have 2. So distributing might not be a bad idea. So let's try it. 1/4 times 8h. 1/4 times 8h. Okay, so you need to do 1/4 times 8. And then times 8, you get 2. Now when you're multiplying in Desmos with fractions, when you do 1 divided by 4, you want to make sure you press the little side arrow over here to move it outside of the fraction. So you want to make sure you move that cursor outside, then multiply by 8, and you get 2. So this would be 2h. 1/4 times negative 12g. So 1/4 times negative 12 is actually going to be negative 3g. And then we have equals k. Now I wouldn't multiply the 1/4 to the k because the 1/4 is attached to the parentheses on the left. The 1/4 has nothing to do with the stuff on the right. Okay, so when you're distributing, you only distribute to the stuff inside the parentheses, and then everything else gets left alone. So goal here is to get h by itself. Here's h. I got to get it by itself. So how do I get that by itself? Well, the first thing I'm going to do is you always add or subtract before you multiply and divide. So you might be like, oh, divide by 2, get rid of the 2 because h needs to be by itself. No, you want to get rid of the 3g first because you can move that by adding and subtracting over. So because it's negative 3g, I'm going to add 3g to both sides. So then I have 2h equals k plus 3g. Okay, so what did I just do here? I moved the 3g over by adding it. Remember, you always add and subtract before you divide. Now, h again is still not by itself, so my next step here would actually be to get rid of that 2. Now I would divide by 2. You always divide and multiply after you've already added and subtracted everything you can. So I would divide this by 2, and that means I would divide every other term by 2 as well. So I would divide k by 2 and then 3g by 2. Remember, terms. Terms are the things that are separated by plus and minus signs. 2 divided by 2 cancels and becomes 1, so I have h equals k divided by 2, cannot be simplified, so it's just k divided by 2. And then remember, when you have numbers like this, you don't want to leave it like that. I like to pull the 3 and the 2 out to the side and put the g next to it. So this would be plus 3 over 2g. All right. Okay, and remember, just a reminder, (3g over 2 is the same thing as 3 over 2g. Just like 3x divided by 2 is the same thing as 3 over 2x. And I'm actually going to flip the order of these. Okay, so those are the same exact thing. All right, now if you're in on level, then you can go ahead and stop watching. And if you're in pre-AP, I would like you to continue watching. We have 2 more problems here where we have to isolate variables. And these are going to be a little bit trickier than the last. Now, here we have m divided by a equals p minus h. All right, now the goal here is we want to get a by itself. However, there's a fraction here. We need to get rid of it. There's no parentheses. There's nowhere for me to distribute. So I have to get rid of the a. Now, just like in that one problem where we had to multiply by a variable, back here, let me find it. Number 5, right? Number 5, we had a fraction, and we wanted to get rid of that h that was in the bottom. So we did the opposite of dividing by h, and we multiplied by h. So over here, I'm going to do the exact same thing. Now, I see that I want to get rid of the fraction, and to get rid of it, I see that it's being divided by a. So in order to get rid of it, I would do the opposite and multiply both sides by a. Now, when I'm multiplying this side by a, I'm multiplying the whole side by a. So I want to make sure I have parentheses there. because I'm multiplying the whole side by a, not just the h. Because if I don't put the parentheses, then it looks like the h is being multiplied. And I want to multiply it to the whole side. Okay? So then a divided by a here, the a's cancel, and I just have m left over. And then I have p minus h with the parentheses and an a attached to it. And I'm actually going to rewrite this because I like to have the stuff that's attached in the front. Does that really matter? Not really. But typically when we put the number, we always want to put it in front. So for example, when I have 3 parentheses x minus 2, and you want to distribute the 3 in, you don't like to keep it at the back because then it looks kind of funny, right? Then you're like, that looks kind of weird. So that's why I moved the a to the front. So I'm just flipping it around. Okay? Now what's the goal here? The goal here is to get a by itself. Well, I want to get a by itself. How do I get a by itself? Well, if you notice, a here is being held back by whatever in that parentheses. And your goal, or not your goal, but your first instinct is going to be to distribute. And I'm going to remind you to not distribute. Do not distribute. Why not, right? If you distribute, it makes it more complicated. The goal here is you're trying to simplify and get it by itself. If you distribute that a, you're going to end up in a mess. And I'll show you what I mean. Right? If I distribute, so I have m equals a times p is ap, a times negative h is negative ah. And the goal is to get a by itself, and now what have you done? You've created 2 different a's here. Not good, right? So you don't want to distribute because it would actually make a mess. So how would you get rid of this? Well, a is being multiplied to p minus h. So I got to get rid of the p minus h. So how do I do that? Okay, well, for example, let's say I had m equals a times 5. So I have the exact same thing as I do over here, except I replace what's inside the parentheses with 5. So how would I get rid of that 5? Well, if a is being multiplied to 5, in order to get rid of the 5, I would divide by 5, right? Or I'd do the opposite. So you would actually do the same thing over here. You want to divide by p minus h in parentheses. And do the same exact thing to the other side. You want to think of the parentheses like a basket. You're taking the entire basket over. You can't just pick and choose things outside of that basket. The whole basket goes together in one piece. So just like over here, if I have m equals a times 5, right? And when I divide, I would divide by the 5 on both sides, right? So then I have m divided by 5 equals a, because those 5s would cancel each other, okay? So you're taking the whole basket over, and you can keep that basket around it if you'd like. So that's what you can do. Now, over here, again, why are we getting rid of the p minus h? We want to get a by itself. A is connected to p minus h by multiplication. So I'm doing the opposite and dividing it out. So p minus h divided by p minus h is going to cancel to 1. So all I have left is a equals m divided by p minus h. Now, I don't have to put parentheses here because there's nothing attached to it at this point. The reason why I had to have parentheses here is because I was stating that it was attached to a. But you can leave the parentheses there if you'd like to, but I'm not going to. Did we do what we needed to do? Yeah, we got a by itself, so we're all good here. All right, number 2. A equals h, parentheses, b sub 1 plus b sub 2, parentheses, all over 2. All right, this is actually the area formula for a trapezoid. So the goal here is we want to get b2 by itself. So they're wanting us to get that variable by itself. Okay? So first thing I see is something that's being divided by 2. I see a giant fraction, essentially, right? So how do I get rid of that fraction? Well, you would multiply by the least common multiple of the denominators. You only have one denominator here. It is 2. So in order to get rid of dividing by 2, I'm going to do the opposite and multiply the whole thing by 2. So that means I'm going to multiply this by 2 on the other side as well. So that means I have 2a over here. And again, you shouldn't have to write the multiplication sign. It's understood that they're being multiplied. And then equals, well, these 2's are going to cancel. And so all I have is h divided by b1 plus b2. Now again, I don't want to distribute the h because it would make it more complicated, right? Distributing the h would actually make it more complicated. Goal here is still to get b2 by itself. Well, the next thing that I am going to get rid of, so that I can get rid of these parentheses, essentially, is we got to get rid of that h. How do we get rid of this h? Well, it's being connected to the parentheses by multiplication. So I'm going to do the opposite and divide it out. H divided by H is 1. So then I have 2a divided by H equals what's left. What's the stuff in the parentheses, right? B1 plus B2. Now, do I need the parentheses? No. So I'm going to go ahead and rewrite it again without the parentheses. And the reason why I don't need the parentheses is because there's no longer anything attached to it. Just like in the last problem, I could drop it because there was nothing attached to the parentheses anymore. Whoops, come on. Oh my goodness. It's getting stuck. All right, we'll just move it later. All right, now again, what's the goal? We're trying to get B2 by itself. Well, what's the only thing holding back B2 at this point? The B1. And how to get rid of B1? I would subtract it to the other side. So I'd get rid of that. And so here's where it gets tricky, right? You want to make sure you separate it. So 2a divided by h was its own thing, and you're subtracting b1 to that. Okay? They don't combine. They're not like terms, so you're just going to tag it onto the back end. Equals b2. And now b2 is by itself, so you've successfully gotten b2 all alone. Now these two are probably some of the most difficult problems. So I would definitely work through these again, practice them, do them multiple times over and over until you kind of understand the process. But again, the goal is to always get a variable by itself. If you have any questions, please let me know. I'm here to help.